Two sides of a parallelogram are 9 and 15 units in length. The length of the shorter diagonal of the parallelogram is 14 units. Find the length of the long diagonal. So the first thing that we want to do, we want to model this situation. We want to draw a parallelogram. It's not going to be the best picture, I cannot promise you that, but I will try to do my best. Okay, so something like this. Okay, so two sides of a parallelogram. So the shorter one is 9 and the longer one is 15. The length of the shorter diagonal, right? So we need to draw a diagonal, two of them actually. This is going to be the longer one. And the shorter one is going to be this one. Okay, so it says the length of the shorter diagonal of the parallelogram is 14 units. So two things that we must be aware of. The first one is that the intersecting diagonals break each other in half in any parallelogram. Okay, so that means we have these two being equal and we have these two being equal. Okay, since the shorter diagonal of the parallelogram is 14 units, this whole green one is 14 units, each one must be 7, right? So this is 7 and this is 7. So we need to find the length of the long diagonal. We need to find the total of these two. If we find one of these, because the two of them are equal, we can find both of them by multiplying the result by 2. So how do we find this side? How do we find this one? Okay, we can label this, let me see, so A, B, C, D. How do we find AE? Because if we find AE multiplying twice, AE will give us the AC. So AC is the question mark. But before we find AC, we need to find AE. Okay? So twice AE, as I said, is equal to AC. If we find AE, we'll be able to find AC. So to find AE, first we need to find this angle. If we find this angle alpha, we can find this side using the law of cosines. So notice that we can use the law of cosines twice in this problem, because we can use this entire triangle ABD, right? 9, 14, and 15. Right, so basically what I'm saying is this triangle ABD has a missing alpha but has a known side, 14, 9, and 15, 3 sides. All right, so this calls for the law of cosines. So now the law of cosines, you have to be careful how you substitute. Okay, how you substitute into the formula. You know that the law of cosines states a squared is equal to b squared plus c squared minus 2bc cosine of a. Okay? All of these are multiplied together, these three terms. So you realize that a squared should be the opposite of the cosine of a, right? So the alpha should be the opposite side of the alpha should be the 15 side. So that means we can do 15 squared is equal to 9 squared plus 14 squared minus twice 9, 14 cosine of alpha. Okay, and let me mark this with red, cosine of alpha. So now if we solve for cosine of alpha, we'll be able to use the cosine of alpha for this side that we need to find, the AE side. Okay? So what is that equal to? Notice that we can algebraically solve for cosine of alpha as 15 squared minus 9 squared, right? Subtracting 9 squared on both sides, subtracting 14 squared on both sides, and then dividing that result by the negative 2 times 9 times 14, right, to isolate the cosine of alpha. So minus 2, 9, 14. Okay, notice that on your calculator should give you 0.263,49206. Okay, notice I'm not finding the alpha angle because I don't need to, right? I don't need to find that because we're going to need the cosine of alpha in order to find the side, the missing AE. You see, you would be going back and forth. If you find your alpha, you will have to still take the cosine of that in this formula, the law of cosines formula, right? So I'm just going to indicate that this is the formula for the law of cosines, right? This is the formula of the law of cosines. So if you find your alpha, you will still need to take the cosine of that into the formula in order to solve for the AE side that we're going to work with when we work with this triangle, ABE. Because right now we're working with triangle ABD, right? This triangle here. So we already found the cosine of alpha. Now we can set up the second equation using the law of cosines. This time the only thing that's going to change is going to be, instead of 14, it's going to be 7, because we're dealing with a smaller triangle now, with triangle ABE, right? So ABE, right? There's this alpha again, which will be here. We know that this is going to be 7BE. We know this is going to be 9AB. And AE is the missing side, right? So we need to find that. We need to find this side. So now, using the same type of equation except changing the numbers slightly, we're going to have AE squared is equal to 9 squared plus 7 squared minus twice the 9 and 7 and the cosine of alpha. So now that's going to give us what? That's going to give us AE squared is equal to 9 squared plus 7 squared minus 2, 9, 7. And we already know what the cosine of alpha is, right? The cosine of alpha is precisely this number that we found, right? So that's, we should write this down. So it's going to be 0.2063,49206. Okay, so as a result, AE, you just take the square root of this and then you'll be fine, right? You're going to take the square root of this whole thing, 9 squared plus 7 squared minus 2 times 9 times 7 times 0.206349,206. You take the square root of that, and this is what the calculator should give you, 10.19803,903 units. Okay, so that's the measure of AE, the length of AE side. Now, if we know the length of AE side, we can find the length of AC, right? The length of the longest diagonal is AC. Okay, so AC is going to be twice AE, as was noted on the top, which is equal to twice 10.19803,903, copying this down, which is equal to 20.39607,806, and we round to the nearest tenth, which will be 20.4 units. Okay, so this is the final answer. This is the length of AC, the long diagonal. So I hope this was useful and fun. Thank you so much for watching. Please subscribe if you can, and I'll see you in the next video.